I haven't posted yet because I didn't want to, but on the Canvas page later, once I post it or publish it is the word I'm looking for, then you'll see that the answers for yesterday's homework are up there. You should not have felt much burn at all on that. That's a pretty straightforward assignment. The worst thing in the world you'd have to do in that assignment is solve a little baby quadratic equation. And they're never even hard quadratics. Like they don't take more than like 5 seconds to factor. So like I said, you should have felt very little burn on that one. The same cannot, please stop. The same cannot be said today. These will be harder. So I'm going to bump us up, but only one little difficulty level. So we're the beginning of this. We're going to start with a skills test first, but when we actually get into the lesson, you won't feel it right away because it's just a little bit more annoying. But before we can actually start solving harder square root equations, I'm going to try really hard to just get in the way of any misconceptions that we have about a skill that is necessary to get through the next couple of days. Without this skill, we won't spend our time talking about what I actually want us to talk about. We're going to spend all of our time talking about a skill that we all should have by now acquired. But it's worth talking about because history generally repeats itself. And I find that it's this skill that gets in the way. So let's start with something that I think we've talked about ad nauseum, but what the heck? Let's say I gave you, trust me, this will come up. Let's say I gave you x minus 6 and said I need you to square that. Please remember this. It doesn't, I feel like no matter how many times I say this, I'm never going to get a full coverage of paint on this wall. I get that. But I feel like I can keep applying coats until it at least looks good. So here comes coat number 39. The most offensive, pathetic, ridiculous, garbage answer you could give for this would be to say that the answer is x squared plus 36. I just need to get that out there right now so that we hopefully don't have to go down this road at all, right? We've talked about this, huh? So our options when we square a binomial like this are, first of all, we do not dare think, bless you, that it's just as simple as squaring the x and squaring the 6. No way, no way. So what are our options when someone asks us to square something like x minus 6? What's one of them? What could I do? Sutter? Write it out. And that's kind of what I'm gonna. I think I eventually I'm gonna start doing it that way every time. Like there's obviously the shorter method, the square square multiply double, but there's no crime or lack of dignity in just saying, you know what, just to be safe, I'm gonna write it out as the thing that someone wants me to square just times itself. And that way there I can see the full 4-step process, right? So this keeps me from saying stupid things like x squared plus 36. Right. That's really the primary goal of these 5 or 6 minutes of this lesson is can we get this out of our system and not ever think it's as easy as square and square and I'm done, you know. So when someone asks me to do x minus 6 squared, I can write it out like this and then run through the whole 4-step process, which is x squared minus 6x minus another 6x plus 36. And, you know, in someone's defense, they might go, what? I thought you said I couldn't have x squared plus 36. Yeah, I get it. It's in there, but there's also that term in the middle, the vexing one, the minus 12x, right? So the shorter way you'll recall, because we talked about this before, but only use this if you're comfortable with it. And I'll give you the same option today. Only use this method if you are like down with how it actually works. And that's the square square multiply double. So remember, you take and identify that as an item and you identify that as an item. And I would recommend circling them or something if you're going to go down this road. Unless you're a pro, then don't worry about it. What is the yellow thing squared? It is. And what is the green thing squared? Plus 36. So there's my x squared and my plus 36. But the key is, remember, this is the last 2 letters of the SSMD, square, square, multiply, double. If I multiply the green and the yellow together, what do I get? I get negative 6x. Double that, what do I get? Negative 12x, right? You see. So it all comes out the same in the end. It's just a matter of how How confident are you in square, square, multiply, double? Like if you feel like I got this, I got this, I got this, then you should be able to plow through. But if you're at all leery and you feel like this is something right here that you might just watch, no harm, no foul, just write it out and multiply it out. Okay, let's practice another couple of these and then we'll get on to the harder ones that have the radicals in them. So how about x plus 8 squared? What do we get? Good. And remember, the answer that gets you kicked out of class is, of course, the ghetto x squared plus 64. That's just a ship that we have to let sail. We have to bid it farewell, let it go, and say bye-bye, right? Yeah, they're in there, but it's that middle term that we often overlook. So another one, let's do m minus 10 squared. What do we get? I'm ready whenever.
Or that's a 10, that's an I and a D, okay.
Perfect. I know this. We literally, you and I will not make it through the next few days successfully as a teacher-student pairing if you can't do that. Like that has to be solid, and it has to be solid every time. Like there can't be those times where we, LOL, oop, I forgot. No, just don't. It's a thing. When you have something plus something and you square it, give it respect, full marks for respect, go all in, and just don't forget the middle term, okay? So let's complicate this a little bit and let's do the same thing, only let's put something that's a little bit more complex looking perhaps. So let's say we had the square root of x plus 5 minus 3. We square this. This is what a lot of our binomial squaring is going to look like today. So you're welcome to take a shot at it first. Like everyone in this room is skilled enough that you can do this. It's just something I've never asked you to do before. But it is in principle exactly the same as what we just did. It is, you can write it out or you can square, square, multiply, double it. But it's infinitely trickier just because of the nature of what you have there. So anyone trying the square, square, multiply, double method? Just want to write it out? Let's do it. Let's write it out. So we have square root of x plus 5 minus 3 times another copy of the square root of x plus 5 minus 3. Remember, squaring something means multiply it by a carbon copy of itself. So if this goes well, then we're looking at a nice, good, relaxing couple of days. So here we go. I'm going to color code for you because this is the time for colors. So here we go. I'm going to start with red. As always, when we multiply two binomials like this, we want to connect the first one of the first binomial with the first one of the second and multiply those. What do you get when you multiply the root of something by the same root? You just get whatever was inside of it. Very good, Sutter. So when you multiply a square root by an identical square root, nothing really massively life-changing happens. You do just drop down whatever was inside the root. You know that already. You've seen it where it's effectively we're just squaring a square root, which is why the square root sign just goes away. Any questions on that? Okay, the second step, I'll go ahead and switch over to purple. And now the next step, any math person would tell you that we generally, as a practice, would go outside to outside. So like far outside of the problem. What do we get there? It's easier than, this one's easy. It's easier than you're probably thinking it is. What is it? Okay, let me ask you this. What if I change this to say X? What would you say is the answer to the purple thing? Okay, what if I changed it to a little drawing of a swirly dongle? What would you say is the answer to the purple thing? Okay, if I could draw, I would draw like a little kitty cat, but I can't draw. It would probably wind up looking like a platypus or a swirly pile of dog feces or something. So let's just pretend there's a little picture of a kitty cat there. What would the answer to the purple thing be? Okay, what if I drew a little picture of a taco? It would be -3 taco. What if I put the word house here? What would it be? Okay, so my question to you becomes, and this is really important because this people turn this into a math problem. What I'm hearing you say is, Mr. Ahern, I get it. Like, I don't really care what you put there. I'm just going to put -3 times whatever you put there, right? Okay, so don't silent treat me this time. If I put back what was actually there, yeah, so it looks mathy. Who cares? What is the answer to the purple thing? It is -3 times the thing that was there. Good job. You guys paused when I asked you that, and you kind of like, I don't know, like what? You don't do anything. You can't. It's not like you can distribute into a square root sign. That root is just a physical object. And when you multiply it by -3, you just get -3 of those physical objects. Now that that cat's out of the bag, let's switch over to green. And this one you probably will not pause on. What does the green one make? Another of exactly the same. You see that multiply double thing coming into play here. That's the same thing twice, as it would be. You can expect that. And then finally, let's go to yellow times yellow. What's that going to be? +9. So let's pause real quick in any questions, give you a chance. Any issues there? Okay. So what we're going to do now is we're going to put some things together. So the first thing I notice is that this X with the white arrow pointing at it, he doesn't have any homies in this problem, does he? And you're not allowed to look at those other X's and say, but it can go with those. No, of course it can't. Those ones are locked up in square root jail. So this X is just basically going to come on down. I do though see that there are these that can go together. Aren't those like terms? Times the square root, right? I mean, again, the hardest part of this, I think, today is to get you guys over the thing you want to think of the square root of x plus 5 as some mathy thing. And in reality, if I'm any good at this, I'm going to try to convince you, or I will convince you, that it's just a physical object. Mason has -3 of those things. We give him -3 more of those things. And then we say, what does he have? We're like, well, I think he's got -6 of those things. When we combine like terms in algebra, the things don't change. Just how many of them we have is what changes, right? And then, of course, I do see some like terms at the back end. I see a 5, that's a just constant, right? And I see a 9, that's a constant. And those, of course, would go together and make 14. Are we okay with this? Cooper, did you have a question?
How do you go checking?
Are you like, where are you at right now in this process?
Oh, God, we have to.
We don't have there wasn't even an equation up here, Brohan. There can't be x equals if there's no equal signs. We're not solving equations right now. I'm just practicing a skill. There's no equal signs on the board.
Oh, equal 0.
I don't see one. Did I put one somewhere?
I figured it.
No, if I want it to be an equation, I'll put an equal sign. We're not solving anything right now there, brother. I'm trying to use 5 or 10 minutes of our time to make sure then that the next couple of days we don't have to sit and keep talking about this, because this is going to happen on almost every single problem. So when that time comes, if you still have that question, let me know, okay? All right. There is no solution. We're just simplifying. I'm just trying to get you, because in a while we're going to have to square both sides. And when I square a side that looks like this, our time is going to be so much more pleasant if we don't have to pause every time and wonder how this became this. Got it? Let's practice again. Now, I do want you to see that if you did take the square multiply double approach, it works slick as can be. Let's practice this again. So let's say we have the square root of 2, oops, sorry about that, the square root of 2x minus 7 plus 4 squared. Would you like to practice without me? Give it a shot. And I'm going to write on the board, just try not to look. You just kind of do your thing on your paper and peek up occasionally if you want to kind of check progress. Good to go, Bryce? Nice job. Get it? Good. It'd be like if you were you ran like a framing, like a construction company where your crew specialized in like framing houses. And let's say you get a crew that's, some of them kind of know how to work a nail gun and some of them kind of don't, right? And then you just don't spend any time first day with your crew talking about how to load the nail gun, safety procedures, just how to use a nail gun. You would find yourself as the crew boss having to stop for that guy and then that gal and then that guy. It's like all the time. It's like, man, I should have just showed them all how to use the nail gun. That's where we are in the process right now. So I just don't want to keep going over this other than right now. So if you notice, I didn't show a lot of the work that we did last time, and I'm going to walk you through the way I do this, and you're welcome to do it the way you did it last time if you prefer. But I like the square, square, multiply, double. To me, it feels clean, and this is how I think of it. I look at the binomial thing that I'm squaring, and I say there are two objects in there. One of them is in a red box, and one of them is in a yellow box. So here it goes. If you guys all with me square the red box, what do you get? You get this right here. I'm going to underline it in red. We agree? If you square what's in the yellow box, what do you get? That's this right here. It's the middle term, and this doesn't have to be hard. If you take the red box and the yellow box and you multiply them together, just multiply them together, what do you get? Don't make a math problem out of this. What do you get? You get 4 times the square root of whatever, right? Again, it's not a math problem. You're just putting things together. And if you double 4 some things, what do you get? Right there. See how simple that can be. It doesn't have to be that long, drawn out 4-step complex process. I hope I can persuade you to really embrace that square, square, multiply, double thinking. It's going to save you time, and it's not hard. You just have to remember the process. And then, of course, there's a little simplification to do at the end. And by a little, I mean like a little. I just took the 7, the -7, and the +16, stuck them together and made 9. Good. Okay, I'm going to give you another one, and I'm going to put it out of order this time. So let's practice again. Good job if you got that right, by the way. Let's do -3 minus the square root of 3x plus 5. Let's square that sucker. I've done this enough to know if I can get you good at this, the rest is easy. It's this part that's the booger. And if you use colors, you'll be at an advantage over someone who doesn't. If you don't have colors, you can use different shapes to identify the objects. But I really am a believer in that your brain needs to see the two physical separated different objects. So you could put like a square around one and a circle around the others. I'll stick with my colors. I view this as two objects. Their names are -3 and -rootitude. Everyone's got to be in a group, right? Everyone's got to go somewhere. So those are my guys. What is -3? I'm sorry. What's red box squared? Good. So we're making progress. -3 squared is not. And then what you're going to do is you're going to leave a nice big open space, and then you're going to go square the yellow box. What do you get when you square the yellow box? You do. And this is important. If you're not listening, listen up. It's plus 3x plus 5. Why did that change to plus? Nice work. This negative right here, honestly, isn't long for the world in that squaring process because squaring a negative. Good job. And then the middle. And I've gone over this in my head every year so many times, and I just wonder, how can I say this better? You really need to identify the objects separated, like I did with my boxes, and then ask yourself, simple, what happens if you multiply red box by yellow box? Just red box by yellow box, what do you get? You get +3 rootitudes. At this point, it's +3 times the rootitude if I don't give a you know what, right? We don't care what's in there. For this part of the process, it's a physical item that I'm just toting around. I don't care what's in there. But if I put those together, red and yellow, I multiply them, I get +3 items. Double that, what do you get? So in the middle, we have +6 items. And then there's one little thing left to do, and that would be to join the constants together. You're going to find those constants to be pretty annoying at the end. So we would have, you could write this, there's not one best order really, because at the end you'll see that it doesn't matter. We're going to move stuff around after this. But how you write it, like you could write it as 6 roots of, I don't care, plus 3x plus 14. You could put it in that order. Like I said, it doesn't matter. Good. All right, then. You feel like you understand that process a little bit? Okay. Please don't forget that. Okay, we're going to take a little detour here, and I'm going to show you the kind of half step up in difficulty, and then we'll get to the worst ones here at the end. So this will be our first like official like equation example. So back to Cooper's point from earlier, now we're actually going to have math problems that have equal signs in them. Can you two quit all your whispering? Good God. Lord, it's relentless. So there, now there's an equal sign, which means now we're solving and we're going to get answers. X equals this or this. This is, I say, so like yesterday, it was all warm up. Today gets pretty hard here in about 7 or 8 minutes. This is sort of the middle ground where we like take one step up before the big step. So what did we learn yesterday? What do we have to do before we can press them? I'm not ready to square both sides yet. Huh? Yeah, and honestly, if you do square both sides, you can use the skill we just learned. But honestly, it's a very non-efficient route. What I want to do always, I would write this down if I were you. I would write this down. If possible, if there's only one radical in a problem, get it by itself. That'll save you time. We're not going to have that luxury in the third and fourth examples today. But in this case, I look at this problem and say, there's only one square root. I'm looking right at it. I want that by itself, which means, yeah, I'm going to get rid of that 9. So I'm going to leave the square root isolated over here on the left. I'm going to move the 9 by making it a minus. And now I'm going to square both sides. And you start to see now the relevance of our warm-up today. You say, okay, I'm squaring both sides. And then the red flag goes up and you kind of go, oh, I see. So here we go. Let's practice. Let's not be rookies and say something ghetto like x squared plus 81, right? What do we get when we square the left side? We love that side. Don't know why I put plus there. That's my bad. And then, oh, here we go. Practice, practice. No mistakes. Square the right side. What do we get? Plus what? Oh boy. There's that skill. And that's not the math problem. That's a little step in the process of a bigger math problem. And you can see how frustrating it is if that's what we get on the right. And then the rest from here ought to feel pretty similar to what you did yesterday. It's now just a quadratic. The hurdle for this example, if you put stuff like this in your notes, the hurdle for this example is going from here to here. I don't doubt for a second that the rest of this is going to be a walk in the park. It's that step that unfortunately is the whooper. All right, so let's Algebra 101, basic skills, instincts kick in. It's a quadratic. What do we do? Come on now, that's not helpful for me, Cooper. I need to know what do we do. I don't want the answer to the problem. I want to know what do I do. Yeah, we get all the stuff to one side, right? So I want my x squared over here. I want to subtract my 2x across to make a minus 20x, and I want to add 19 to make 100 like this. All right, remember what we do in quadratic fill is always just get everything to one side, set it equal to 0. And now it's an equation that we do need to solve out. And the factoring is just going to keep working for you. Okay, I'm not going to make you use the quadratic formula or anything like that. So nothing to it. How would this factor down? Right. And what that means is really this equation has one solution, but that solution has a multiplicity, we say, of 2. Like on a graph, it would just touch the x-axis and back off. So that means that x just equals 10. And then, of course, going back to a question from earlier, how do you check your answer? Exactly the same as we did before. So if we claim that 10 is an answer, then we want to go back to the very beginning of the problem. Anywhere above this yellow line is fine. Remember that yellow line, I call that the funk line. That's where the funk happens. Because when you square, bad things happen, right? So anywhere above the funk line is fine. But if you take 10 and put it anywhere, so like where the green arrow is pointing, like right, it doesn't matter. Let's do like this one right here. That's fine. So if you put 10 right there, what's 2 times 10? What's 20 minus 19? And the square root of 1 is 1. And then put 10 right over here. What's 10 minus 9? Everything's fine. It all checks out. So x equals 10 can have his box, and we are on to the next one. So you would agree that's just a slight step up in difficulty, hey? Would you like another example of that level? One more, and then we'll press on to the hard ones. Okay, one more. So for this one, we are going to have 6 equals negative x plus the square root of 7x plus 60. Hopefully you wrote that bit of decent advice down. If there's just one root, get it by itself. You could square both sides here, but as you'll see in the next examples, you want to avoid that. So let's move the x while I pour some coffee. You guys get the x moved across, square both sides, and then I'll get caught up to you. Ready? Did you do the step? If you want to take a peek, make sure, I'm assuming you've gotten this far, take a look, make sure we're all on the same page. Good. Move the x, of course, in the first step, it becomes positive x, square both sides, and the step of death and doom is from purple to purple. I wish it weren't the step of death and doom, but every year it is. We good there? Right on. What do we do now? Yeah, get all your stuff to one side. Good, well played. So the x squared is like, I'll just kick it here. Thank you. 7x comes across and makes 5x. 60 comes across and makes negative 24. And there we have a little baby simple factorable quadratic. What does it factor down into? There you go. Need those signs there. Good job. So what are the candidates for solution? Good. So just like yesterday, this is never going to like not be an expectation. You got to check your answers. Like, are they going to cause any trouble? So let's start with, go back up to the top. And remember, our candidates are -8 and +3. I tend to like, I don't know why, I like plugging them into the kind of more, I don't know, this one just feels better. The one in the yellow box just feels better to me personally. So I like to put them in there. If I put in -8, what happens right away? Say it again. Yeah, I'm not worried about that. So let's talk about, okay, follow the arrows. That red arrow is not a concern. I didn't really I didn't think you'd go there. But yeah, if we put -8, yes, we get -56, but it's not really a -56 because then you got to add 60. And what's -56 plus 60? 4. So that's not a concern. I can deal with the square root of 4. My concern is what happens over here with the big fat green arrow. Put -8 right there. What do you get? And as we learned yesterday, you cannot have a square root equal to a negative number. The moment that happens, we rule that answer out and say that's never going to happen. Okay? So in this case, it's not about what's happening inside the square root. It's about what the square root can't equal on the other side, and that's a negative. So -8, you can go ahead and cross that one off. The other answer we got was 3. And if you put 3 where the big fat green arrow is, you get 9. And if you put 3 where the little skinny red arrow is, which is 81, and the square root of 81 is, and 9 does equal 9, so 3 can have a box, and -8 can go ahead and take his cross out. So 3 is a yes, -8 is a no. So you good on that difficulty level? All right. Now come to poopy ones. These are hard. But as has been the case all year, I say something's hard, and then you guys go, oh, that's not hard. So I hope that's the case again. It's just don't cease to amaze me this year. So the casual observer would look at that and say, oh, didn't we already do this yesterday? And the answer is no, we did not. This is oops, I'm sorry. I'm supposed to put a square root on this. Will you please look up here right now and add that square root? This is a big deal. So you right away go to the idea of get the root by itself, and then you're vexed immediately and go, there's 2 of them. Which one do you want me to get by myself or itself? And the answer is, it doesn't matter. Like at this point, you're going to have to square a messy side either way. Bryce might say, well, let's move the 2 over to the left side. And I go, whatever, that's fine. But you still are going to have one of your radicals with an extra bonus number at the back of it. I'm going to leave it on the right because I like it as a positive. So here we go. So we just square both sides. And this is where the warm-up today kicks in. If I square the left side, that's light work. We don't ever miss that. It's this side. Here we go. Here it goes. We're going to square the right side. Oh, yeah. Hopefully the warm-ups would have served their purpose and we will get this perfect. I'm going to use colors. I'm going to use a little yellow box, and I'm going to use a purple box. What is the yellow box squared? What is the purple box squared? So I'm going to leave a space and put plus 2x plus 3. What happens when you multiply yellow by purple? You get plus 2 roots. I don't care what's in the root because I'm not unrooting it at this point. And what happens if you double 2 roots? So I'm in the middle going to put plus 4 of the roots. So far, so good. Kitoki. Very critical step now, and that step is to re-prepare this equation for round 2. And there is a round 2 because it's weird to think that we just squared both sides of an equation and look, a square root survived my onslaught. That 4 times the square root of 2x plus 3 is like standing there making obscene gestures at us like, you couldn't get me. So we have to go back in and essentially apply another coat of awesome mathematics to this. And before we do that, we want to take some great care to prepare this intelligently. So what we want to do now, I hope I haven't lulled you to sleep. What a terrible time if you've reached the scientifically proven drowsy stage, because don't sleep now. What we have to do now is get this green thing by itself. We have to prepare this for round 2. And round 2 is going to be another squaring. We have to do another squaring. But if you try to square right now, woo, holy, that's a mess. So what we're going to do is we're going to now say, everyone, if you are not in the green box, I need you to head west. Get over there. Go out. So we're going to leave the green box over here. And then we're going to say, all you guys, 4, out. 2x, out. 3, out. Everyone, go. So let's combine some like terms here. If I subtract the 2x across, what will I get? I'll get negative 12x. And if I take, I'm going to color code this for you. If I take this 4 and this 3, and I add them up, I get 7, right? And if I move that collectively as one group of 7 and I subtract it to the other side, I get negative 8. Are you with me still? Now, at this point, you have a decision to make. And sometimes the answer to this question is going to be different than other times. But the big question here is, how hard do I want to make the next step? And it's like, I don't want to make this hard. So what I'm going to do is I'm going to look at these 3 numbers. I'm going to point to them with cute little red arrows. And I'm going to ask you if you notice anything about them all. We should divide them all by 4. If we don't, the next step is going to be a lot worse. So let's divide every little number with a red arrow pointing at it by 4. And if we do that, what do we get? I'm sorry, try that again. Negative 3x minus 2 equals just the square root of 2x plus 3. What's interesting about this is I feel like we've been hitting this problem now for like 4 minutes, and we now are just at what would sometimes be the beginning of any other problem. But we're prepared now to do the last step, which is to now square again. And this will be the final. This is the, sometimes you got to give 2 applications of the bug spray. Like this one, the bug is the radical, and we had to apply a second application. But this time he's not going to survive because there's no hijinks going on his side. None of this square, square, multiply, double on the right side. So let's do this. It's time to square again. Square, square. I'll give you about 10 seconds to work out the left side, and then you'll let me know what you got. Okay, I think time's up. What do we get on the left? Nope. Plus 12x. You did a great job of square, square, multiply. You just forgot the double. What do we get on the right side? And now we finally arrive at what feels like the ending. Thank goodness. We've got ourselves a quadratic equation. And it's going to be a little tougher because there's a coefficient, but we're tough. We can do this. So now that it's a quadratic, where does our mind go? Yeah, move all the key wrap to one side, eh? So let's leave the 9x squared as it is, and 2x comes across. What do we get? Plus what? There you go. Did you say plus 1? And now we're going to factor. Factoring on this one should be obvious, but I'll give you a moment. The 9 and the 10 should be just yelling at you. Is that? Yeah, listen, if you put a 9x here and a 1x here and a 1 here and a 1 here, I mean, that was just destined to happen that way. It's just, there's no way around it. Look how beautiful it is. 1x, 9x, 10x, gorgeous stuff right there. What are my answers? Negative 1,9. Thank you, voice of reason there. And now we have the distinct honor of getting to check those because we're lucky like that. So our candidates for answerdom are negative 1/9 and negative 1. Negative 1/9 and negative 1. Which one do you want to test first? Negative 1. Get the easy one done first. Okay, let's do it. So here we go. I'm sorry for all the vandalism, but you have to have laser-like focus. We are going into the red box. Ready, set, go. And we're using negative 1. If you put negative 1, I'll make the X's red so we can really see them. There's 1 there. and there's 1 there. So if you make those red X's up there into negative 1s, what will the first square root say? Plus 10, which is 9, and what's the square root of 9? Nope. So we have 3 equals. Let's go to the right side and put in X as negative 1. 2 times negative 1 is? Negative 2 plus 3 is? Square root of 1 is? 2 plus 1 is? 3 equals 3. So I say to X equals 1 or negative 1, I say, you, sir, have earned your box. Negative 1/9. Listen, I fought this battle every year as to like what do we want to do? I got to be honest. It's okay to use a calculator if it comes to that. Like these are hard, and I don't know when it was, like last year sometime, where I finally just acquiesced and said, you know what, let's just put them in our calculators. And for those of you that don't want to, don't. I get it. But if you just go take your calculator and grab your calculator right now. Grab your calculator if you have one. If you don't, you just want to watch us do it, that's fine. So if you take what I've written down there are the things that are inside the square roots, because that's where the variables are. So if you take a negative 1/9, the way you type this into your calculator would look just like this. So you just type in, here, I'll do it with you. So we just do negative 1 minus 10 times. So I just use parentheses and I put negative 1 divided by 9 and I close the parentheses. And I got something very unexciting. I got 0.1 repeating. Who cares, right? So just kind of keep that, write it down. Remember, that's of no concern yet. I'm like, you're positive, and that's good news. So now let's take the other side and let's put in negative 1/9. And again, you just type it in as 2 times negative 1 divided by 9 plus 3. So I type in 2 parenthesis negative 1 divided by 9 close parenthesis plus 3, and it equals 2.7778. They're not the same, but they don't have to be the same. And the reason they don't have to be the same is because this side has, where was I? It has this, right? So let's think about this. If the left side equaled 0.1 repeating, which is what it did, and then we have 2 plus 2.7 repeating, what would we say? Do they equal each other? Then we cross that off. These ones are a pain in the butt. I know my lesson's dragging on when I put Sutter to sleep back there. Poor Sutter. Did you have too late last night, Sutter? Oh. Right. That's the process. Oh, so by the way, let's make this official. X equals negative 1/9 can go ahead and take one of those. Right. This time, let's practice again. I know you're so over and done with me, but let's get this done, and then obviously you'll have a nice chunk of work time on Monday. So I'll still give you the assignment if you want to work on it. If you're one of those people that just wants to go, I get it. So last one for the day. Long recording here. Sorry, not sorry. I hope you enjoy this process. I will assist you with the beginning portion, and then I'm going to try to step out of the way a little bit and let you try to grind through this. What's different about this and the last one? Right, and you should avoid that, honestly. You trust me, don't do the square both sides step when they're on the same side. It sucks. So I personally think, if you disagree with me, you're crazy, but sorry, I would move that one. Why? So then I got positives everywhere. Why move something and then make more negatives when you had the option to make it so clean and pretty? So when we are like all set and good to go, it's going to look like this. And at this point, I'm going to pause the recording, give you about 3 or 4 minutes, see if you can make some progress, and then I'll periodically sort of get in here and see how we're doing along the way. All right. having seen there's the one step here, I'm not simplified and prepped and ready for round two of application of bug spray, but any questions on how we got from top to next line? Other than using colors and color coding it, the only other thing I can tell you is to write it out, to write that right side out. Rudy 2 plus 4 times Rudy 2 plus 4, get down with your bad self. I maintain that it's just quicker. And once you get the square multiply double, it is easy. Way to go. All right, so I'm going to start prepping for the next step and getting us ready for the second go round of the bug spray here. So. Guessing you know that that's probably annoying, but I'm just going to point that out anyway. So there you go. You got to probably not do that. Thanks. Take this opportunity to say, if you made it this far to where I'm at, seriously, kudos. Like I don't consider what just happened to be light work at all. That process of getting through the first stage of these problems, it sucks. So again, good job if you made it here. The reward here oftentimes is that everything can be divided, and it feels good when this can happen. Like happened in our first example, when I look at this number, and this number, it doesn't take a math degree to figure out, hey, I can divide them all, and you should, because dividing makes numbers smaller. Smaller numbers are good. So if I divide them all by 8, and I wind up at negative x minus 2 equals Rudy toot. And we are now prepped for round 2. These are nasty. They're like 2 full math problems for the price of 1. There's no way around this, by the way. It's not like there's a workaround. At some point, you have to square again, because you cannot eliminate 2 roots in problems like this. That extra number, it makes all the difference. That little extra bonus thing at the end, like a plus whatever, minus, those things suck. All right, so we made it. We prepped it. We got to here. It's time to re-square. So I am going to square the left side and square the right side. When I square the left side, again, my thinking is to think of these items physically as separate entities. And I'm going to square, square, multiply, double them away. When I square the red box, I get x squared. When I square the yellow box, I get plus 4. When I multiply them into the middle, I get plus 2x. And when I double that, I get plus 4x. So that's my square, square, multiply, double step. And then the right is, of course, just a joke. When you square just a root, you don't need any fancy stuff for that. You just, so we'll just take it free. And then finally, we feel like what once would have been a math problem that we had on a test is now just the final step. Simple. So I'm going to add my x across to get 5x. I'm going to add my 2 across to get 6. And I'm going to factor. And the factors for this are x plus 2 and x plus 3, which means that the solutions are x equals negative 2 and x equals negative 3. And then it's time to vet those. By the way, did anyone make it this far? Excellent work. Top notch for real. It's impressive. That is not a simple math problem. So we're going to take negative 2, negative 3. We're going to go back to the beginning of the problem. And I mean the very beginning of the problem. Anything above this yellow line is fine. Okay, remember the yellow line is the cutoff. And our answers are negative 2 and negative 3. If we put negative 2 here, we get negative 2 plus 18, which is 16, which is 4. And if we put negative 2 here, we get negative 2 plus 2, which is 0. Square root of 0, 0 plus 4 is 4. Negative 2 works just fine. So negative 2 can have a box. There you go, buddy. Have a box. And then try -3, and you will see the same thing happens there. And you get -2 plus 27, which is 25, which becomes a 5. And then -2 plus 3. So listen, I'm gonna stop the recording here because I don't want to admonish anyone while recording. So I'm gonna say bye to the video. So bye video.